All right, let me start. I'd like to welcome everyone to the virtual seminar on climate economics. I'm Glenn Rudebush, a senior fellow at the Brookings Institution, at the CEPR, and at the Stern School of Business at New York University. Although the virtual seminar on climate economics has been around for almost 5 years, this is our first seminar with the Center for Economic Policy Research. With this new home, I'm also pleased to welcome my new seminar co-organizers, Ma Reguant from Northwestern, Fran Moore at UC Davis, and Lint Barge at ETH Zurich. Our speaker today is Daryl Fairweather. Daryl is the chief economist of Redfin, a preeminent technology-powered real estate company. Prior to joining Redfin, Daryl was a senior economist at Amazon, and during the housing crisis, she worked at the Boston Fed, studying why homeowners entered foreclosure. Daryl received her PhD in economics at the University of Chicago. Today, Daryl will talk about expecting climate change, evidence from a nationwide field experiment in the housing market. There will be 50 minutes for her presentation, followed by 25 minutes for questions and discussion. To ask a question, type it into the Q&A and raise your hand. During the presentation, we will cover some clarifying questions if needed, but the bulk of the questions should come after the presentation. We are recording this seminar for posting online, but we are not recording the Q&A session. Daryl, thank you very much for joining us, and the virtual floor is yours.
Great. Thank you so much for having me. So this research paper is about expecting climate change. It's based on a nationwide field experiment on the housing market that was conducted at Redfin. And before I start, let me just kind of tell the story of this research paper and how I got involved in it. So I'm the chief economist at Redfin. I've been there for a little over 6 years now. My job at Redfin is to study the housing market and deliver insights on the housing market to our real estate agents, to our executives, and to the public at large, like our potential customers. So it's always been a part of my job to do research using our Redfin data, which includes data from the MLSs on transactions. It includes our Redfin search data from our users, and it also includes the data of our customers who sell and buy homes using our brokerage. So back in 2020, we were exploring adding more data to our website, to the listing details, the home details. On Redfin, there's nearly every home in the United States, whether it's for sale or not. And underneath those homes on the pages, there's all these details about the number of bedrooms or the walkability, the school quality. And we're always trying to add new information to our app and website. And one thing we were thinking about was adding climate data. There was one product manager in particular who felt really passionate about climate data being something that would be valuable to people buying homes. But I think our concern came from whether sellers, homeowners would welcome or use this data as much as buyers. So because of that hesitation, but also because of our conviction that this would be good for home buyers, we did an extended experiment where for 12 weeks, half of our users saw flood risk coming from First Street Foundation, and half of our users did not. And at a business level, we were mostly measuring engagement with the data and also if we got any complaints about the data. After this experiment concluded, we had enough evidence to move forward and put the flood information out there for all of our users. And we've also added other climate scores from First Street Foundation. But since we added this natural field experiment, I felt like there was really great research value in it from an academic perspective. So I teamed up with an intern, Sebastian Sandoval Olascuaga, who was a urban economics PhD student at MIT. And I knew Matt Kahn from his climate work, and Rob was his colleague. So we all got together and made this happen. So that was a long preamble, but I think it helps just contextualize what this experiment is. Okay, but now on to the presentation. So the motivation for this kind of research is climate change adaptation. Adaptation is going to be a major factor when it comes to the welfare change from climate change. So people, they know climate change is coming to a certain extent, and there are things that they can do personally and community-wide that could make the harm from climate change lessen. There are many different margins for individuals and for companies that they can change their behavior on. One is where people locate, and one is where they put their money and invest their capital to defend themselves against climate change. There are not many well-identified studies on how these changes might occur. Massetti and Mandelson is one example, but our study, I think, is different because we examine whether adaptation can be forward-looking. Our climate scores are not just about current risk, but also future risk, or at least the flood score is about current risk and future risk. And we can look at whether that forward-looking information causally changes consumer behavior. So we're looking particularly at flood risk. This was the first risk factor that was available and that went on the Redfin site. Floods are very important to the real estate market. Flood-related events cause more direct economic damage than any other type of natural disaster in the world. And we're using a hedonic model about how flood risk is a factor in the value of homes. If there was perfect information, everybody knew about flood risk, then you would expect flood risk to already be capitalized into the market. But that's a pretty big assumption that we're going to investigate in this paper, whether people know already about flood risks with homes and whether it already is capitalized or not. The reason to think that people do have this information out there is that flood insurance exists, and flood insurance, in theory, should be a good reflection of the costs of flood risk. And it's easy to figure out for a home how much flood risk costs. So with perfect information and rational behavior, you might expect flood risk to already be capitalized into the market, but we find something different. And also, just the way that flood risk works, it's not surprising that not all the information is capitalized, because the FEMA flood risk score has its problems, and it doesn't reflect like every dimension of risk either. It doesn't reflect future risk. It's only about current risk. So more about FEMA. FEMA is used to determine what mortgage risk is for banks. It's used by insurers to insure against flood risk. It's used by planners, builders, and land use regulators to understand risk. It's also used in flood mitigation efforts. It also helps individuals, consumers, citizens just understand risk. But there are pretty big shortcomings in the FEMA data. It's not updated very frequently. There was an update, I think, in the last couple of years, but it doesn't get updated continuously. It misses a lot of the US market. There are a lot of political interests and stakeholder interests that kind of skew how the score is determined. It only uses historical flooding data. It doesn't take into account things like sea level rise or surface and sea surface temperatures. It misses pluvial and fluvial flooding. Fluvial is flooding from sewers and fluvial is flooding from rivers. So there's a lot of reasons to think that FEMA is not this perfect indicator of flood risk and that it can be improved upon. More about the stakeholder thing. They need agreement from all the stakeholders, so the flood maps can not necessarily reflect risk, and we saw this in Superstorm Sandy, how the flood maps did not predict the storm surge that happened there. And there's also an example in New York of the political nature of FEMA maps, but I'm just gonna kind of breeze through that because it's more of a historical note. Okay, so First Street Foundation. First Street Foundation is the provider of the flood score that went on Redfin. First Street Foundation is a group of 80 scientists, economists, and technologists. They have many inputs to their models like precipitation frequency, river flows, tide and surge data, elevation data, et cetera, et cetera. I'm not a climate scientist, but from what I understand, it's very good. And I've talked to a lot of reporters recently about like why Redfin chose First Street Foundation, because there are different providers out there. A lot of it just came down to business decision that their product looked nice, it was available, it had a good reputation, it was at a price that worked for us, and that's why we chose them. There is not going to be a perfect climate score, and it's hard to test which climate score is more accurate. So I think that's the whole other topic of research is like, how do consumers interpret climate scores in relation to themselves, like if there are multiple sources of truth. All right, more about First Street Foundation models. So they include adaptation measures like levees and seawalls. Adaptation, has political influences there too, so it can be a bit tricky to model, but they do try to include it. They run for different climate scenarios, but the default is the median model, which is RCP 4.5. It assumes, I think, 4.5 degrees of change. But Glenn, I'm not a climate scientist, so I just know it's the default one that the climate scientists use, the model for how much change there will be in temperatures. It's open source, it's transparent, it's peer reviewed, it's been cited in these different research papers.
Yeah, it's not actually temperature. It
Oh,
has to do
sorry.
with it has to do with some radiation, but
Okay.
it's yeah, not as bad as 4.5. 4.5 is sort of a probably a 2 to 3 degrees warming
Oh,
in
okay. Great.
Celsius.
Thank
So
you.
yeah,
Yeah,
sorry.
I think I do remember reading that, but thanks for
Yeah,
clarifying.
sure.
Okay, where was I? There are many different factors that can go into a flood score. Boiling it down just to one number or one color obviously flattens information, so that's something to consider here. And, as I talked about, it's not the only source of truth. I mean, FEMA is just another point of information. The FEMA scores did go up on the Redfin site at the same time as the First Street scores. Like, if I'll show you later, but users did have access to both scores, the FEMA score and the First Street score. But as you can see, it's not exactly the same information. So about 1.7% of homes are deemed in the FEMA zone that requires flood insurance. But in First Street data, it's 4% of homes are in the severe or extreme risk category, which is about, it's comparable to you need flood insurance for this property. So there is added information too, because there's just more dimensions. It's not binary. Like with FEMA, there are these different scores in between. And also, in terms of the distribution of the experiment, for Redfin users, about 83% of the homes that they were viewing were in the 1 to 2 minimal and minor category of flood risk. 15% were in the moderate or major category, medium flood risk, as we define it in the paper, and 2% were in the high flood risk category. The high flood risk category is going to be the one that we're going to pay attention to most in this paper. So important to note here that it is a small share of people who search Redfin who are searching primarily for high flood risk homes. And also, so here's just a sense of what these scores map to. They map to the probability of flooding within timeframes. If a home has a score of 1, it means there is close to 0% probability that it will flood in the next 30 years. Once you get up to a 2 score, there is a risk starting at the 10-year probability. And then as you can see, as you go down, how the flood risk scores. For a score of 10, you pretty much have a very high likelihood of flooding by 10 years, and even within the 5 years. On the website, there's also a 1-year probability. We don't show this in this chart, but you can also get like the immediate flood risk. So what do we do in this paper? Well, there's this nationwide field experiment that I discussed earlier that Redfin ran in 2020 with all of our Redfin users who were active on the site at that time, either entering into the control group or the test group for seeing flood information. Redfin is a residential brokerage. We have 20% of the search market for homes, but only 2% of the transaction market. So Redfin, I guess the way to think about it is that we're a very popular website and app, and a small portion of our users end up as home buying or selling customers of ours. That's important for this experiment because I'm going to talk about people making offers on homes. When it's people making offers on homes, those are Redfin customers, only 2% of the market. When I'm talking about people searching for homes, that is Redfin users, and that's 20% of the market. So lots of people use Redfin, but then they end up either not buying a home at all, or they use a different real estate agent or no agent at all. First Street Foundation has 100% coverage of homes in the United States. Our hypothesis in this paper is that providing flood risk will provide new news to consumers and alter their searching and buying behavior. So new news is this concept that, is there information out there that consumers do not have that would be valuable to them when deciding whether to purchase a good or service? So in this context, it means that there's information out there about flood risk that is unknown to home buyers. And if they knew it, it would change their behavior. So that's what we're going to be measuring here. I talked about this earlier about how there is some information out there about flood insurance, but it's not complete, and this will add more information to people's information set. All right, and we're going to build on this previous literature on hedonic models and how, products have features that alter their value, and also the literature on expectations in the housing market, how people's expectations about home values alter their buying behavior. And this literature exists like for the housing market, but also there's been research on that in climate change broadly. I know there's research on looking at FEMA, the change in FEMA maps and how that altered home buying behavior. So, but our paper is experimental, so unique there. All right, and we have two clear predictions. One, that consumers will be affected, that they will change their behavior once they see these flood scores. And we also believe that people who, when a home is saliently at risk of flooding, like it's on the beach, that those homes won't be as impacted in terms of their desirability compared to homes where it is not so obvious that the home has flood risk. So trying to test that new news importance. One way we look at that is by looking at homes that are inland, i.e. not on the coast, on the ocean coast, but that have high flood risk designed by First Street Foundation. So, oftentimes when it's fluvial or pluvial flooding from rivers or from sewers, it's not so obvious that there is flood risk compared to when it is just on the beach. And we also predict that consumers will not be affected if the FEMA designation already clearly indicates high risk. That means that there wouldn't really be new news if it, on top of that, has high risk coming from First Street Foundation, or at least there would be less new news. And also, we don't think that there'll be impact when people aren't considering flood risk to begin with. Like if they're searching for homes with 1, 2 scores, and then they're not going to really care about the flood score if it's not something that impacts the homes that they are specifically looking for. So we wouldn't expect an impact in, Arizona. Well, I don't know. There's probably some flooded areas in Arizona, but generally, the less flooding there is, the less of an impact we would expect. And what do we not do? So we're not going to talk about mechanisms. So, for example, it's just impossible to know the way that people are internalizing this flooding information. Are they believing that they're going to have higher maintenance costs? Are they believing that their insurance costs are going to go up? Are they believing that the home value is not going to appreciate as quickly? We don't know what channel they're operating on when it comes to how this flood risk would impact their decision to buy a home. All right, so a little bit more about the Redfin app. This is what the Redfin app just typically looks like or looked like in 2020. If you were browsing, you can search by all these different filters like price and home features. There's a map feature to look for homes where the prices are right there. You can get notifications, you can make favorites, you can save searches, you can request tours. That's how you would enter the channel for being a Redfin customer in terms of buying a home. Here are just some more screenshots if you aren't familiar. All right, so here is the control panel, what you would see if you were assigned to the control group. And this is what you would see if you were assigned to the treatment group. So you can see in the treatment group, there is this panel or this click-in for flood risk right below public facts and above the Redfin estimate that you would see as a user. And when you click on flood risk, it would open up this panel that gives you more details about the flood risk on a home. So this is the different worlds that you would live in if you were a user in the control group versus a user in the treatment group. And later on, we added more factors to the website from First Street, including fire, heat, wind, and air factor, where you can click in and see those similar risk factors. But those didn't come online until after this experiment was over. Oh, and here's another example of what flood risk looks like when you click on it. So you can see the 1-year risk, the 5-year risk, all the way out to 30 years. You can see the FEMA zone. You can click in to First Street Foundation to see what it looks like over on their website. You can click for information about flood risk from the government. Yeah, so there's more here for people to learn about. Okay, so I'm going to talk a little bit about how we did the randomization. The natural field experiment had 17.5 million unique users. I know that's kind of mind-boggling, but when I said it was all of Redfin users, I really meant it. 8.73 million in the treatment group, 8.73 million in the control group for 12 weeks between October 2020 and January 2021. The way the randomization occurred was that when you opened up your Redfin app for the first time during this period, you would at that point be assigned at random to the control group or the test group, and you would stay in that group for the duration of the experiment. If you were a registered Redfin user, we know 100% that you are going to be seeing the exact same. You're going to stay in your control group or you're going to stay in your treatment group. If you were browsing Redfin, but you were not logged in, you would be assigned control or treatment based on your IP address. But if you were if you're not a registered user, you're searching one day from your office and the next day you're searching from home, you might be half in the control group, half in the treatment group. It shouldn't really matter for this experiment, but just something to be aware of, that there are those non-discrete cases of people changing control and treatment. Yeah, it's basically equivalent to it fits all the restrictions that you would want. If you boil down to it, you could have just assumed that we assigned everybody control or treatment before the experiment even began. It's kind of inconsequential that it was assigned at the time that they entered the experiment, because we kept people in their groups unless we didn't know how to identify them, if we're identifying them based on IP instead of on username. Any questions about that? No? Or
No, I don't think so. I think,
okay.
or maybe.
Yeah, just a clarifying question. So of those 8 million people in the treatment group, how many of them registered fraction-wise? You get a sense.
Well, we can see the cumulative number of users in the experiment rises to a little under 7 million. Oh, wait, this is control. Yeah, a little under 7 million for both groups by the end of the experiment. So it does look like some people were assigned, but like didn't have an outcome, perhaps. I'll have to check and see why that number is lower. But
most people are registered, it seems, right?
Yes, yeah. It looks
I
like
can help here, Daryl.
Yeah.
So it's
Thanks, Sebastian.
we
my co-author Sebastian. I should introduce him.
We got exactly, we got almost half. So here you can see at the end of the experiment, we got almost 7 million on the treatment and 10 million on the control.
Yeah. Out of the 8.7 that it would have been.
Yep.
Yeah.
Seems to me like
go ahead.
It seems to me like if you have individuals who aren't registered and you treat them as control or not, some of them may end up being treated, and that would reduce your effect. Have you looked at it just with registered users as well?
Well, this figure here is the number of registered users.
Oh, I see.
Yeah, well, when we get to the results, I'll double check whether we're including the non-registered users or not. But we did test whether, like, being I guess the level of engagement, whether that would matter.
And adding to that, the idea of using registered users is that to make sure that the same user sees the treatment as long as you go, you need to find a way, because you assign treatment based on your computer cookie or this type. And how we do in the back end is by just focusing on registering users, we are able to know that someone, perhaps you or someone else, is using the same across devices. We're able to link them and make sure that we just stay with the ones that only see the treatment and only see the control.
Okay. I'll keep going.
Great.
Okay, so yeah, this explains it one more time. Registered users, we know everything about their search behavior, their engagement with properties, their likes, their home visits. If they're registered on the website, then we can track them all over the website, the app, and if they go on any home tours, we would know it too. For unregistered users, we know everything about their search behavior, but in terms of their engagement metrics, it's harder to piece it together. You know, if you're not registered, you're not making likes on the Redfin app, that wouldn't save. And if you're going on home tours with some other agent, we wouldn't see that. I guess we wouldn't see that for registered users either, but we definitely wouldn't see their likes if they aren't registered. And we also have data on all the MLSs and properties sold. And we looked at whether the experiment was balanced. And as you can see, it looks very well balanced with the same number of control and treatment or just about the same number in each flood score category. And that's true for registered users and also for the unregistered users. Okay, so we are going to analyze we did analyze the search behavior of users. We analyzed the behavior of Redfin customers who make offers and bid on homes. We see their tour behavior too. And we do an equilibrium hedonic analysis of information on the housing market. Okay, so just to give you a sense of what the typical Redfin user looks at, they are looking at 3.5 bedroom homes, so a little bit bigger than the typical home, 2.7 bathrooms, 2,300 square feet, $700,000. That's above the national median, or was above it at the time. I think it still is. Homes that are typically built in 1971 and homes that are kind of suburban in terms of their walk, transit, and bike scores on the lower side there. So not exactly like the typical home buyer, because the typical home, I think, tends to be smaller and not as expensive, but you know, a middle-class home buyer, I guess you would call them. So we do a regression analysis, pretty simple linear regression with observations for individuals and at time frequencies. So our main result is that the search to flood score of homes does go down with treatment. We're going to break this result out always by the flood score that people were previously searching for before they entered into the experiment. There was almost always no effect on the low group. So people who weren't looking at homes with high flood scores before the experiment continued to do what they were doing. They didn't change their behavior. For the medium score, you know, arguably there was an effect, but definitely an effect for the people looking at high flood risk homes, those extreme and severe scores. I think it was like 8 to 10, maybe it was 7 to 10 on the First Street Foundation flood score. We saw a decline of 5% in the flood score of the homes that they went on to search for once that information was available. And there was also seemingly an effect from time. The longer users were in the experiment, the more their search behavior was altered. And that's for that high risk group, because that's where we saw the effect.
Daryl,
Yes.
we have a question from Fran.
Yes.
Could I just ask a quick clarifying question here? So when you
Sure.
say searched flood score, can you just like spell that out a little bit, exactly what that means? Like, were people able to search by flood score, or is this more about like they were searching for some other dimensions and then they were kind of engaging with houses with like lower flood scores if they were in the treatment group?
Yeah, let me go back to the regression. Well, the outcome here would be, well, this isn't very useful. I'll just explain it. So the outcome we're looking at is the average weighted by like frequency of views flood score that a user would look at on a given day. So there is a search criteria on Redfin where you can search for homes that are coastal or that have views of the water. But at this point, there was no way to filter by flood score.
And so how did they, so kind of what's the mechanism? So they saw the flood score and then didn't click on it if it was a high flood risk? Is that what I should be thinking of?
So we know, I can get, there might be slides on this later, but generally like what at least I think is happening is that people would be interested in a home. They dig into the details on Redfin, you know, what's the what's the school quality, what's the walk score. They would see the flood panel, click on it, and then get this information about flood risk for the home. Within that panel, there was a map that would kind of show at a metro level
I
or
see.
a neighborhood
Yeah,
level.
yeah.
You can zoom in and out to give you a broader sense of what the flood risk was.
Uh-huh.
But it wasn't necessarily that channel by which people were searching. I think it's more likely that people view homes that they're interested in a lot, and
Uh-huh.
the homes that people were more interested in tended to be those homes that had the lower flood score. They might view a
Okay.
home with a high flood score once and then eliminate it based on the high flood score, and then concentrate their like top list into the homes that had low flood scores. And
Got it.
I'll
All
look
right.
at this outcome later, but we did look at homes that were liked, and there was an
Mhm.
impact on homes that were liked. So we know that people are like choosing their favorites differently based on the flood scores that they saw.
Got it. Thank you.
We also have a question from Tuan. I should mention that these questions won't take away from your 50 minutes. So this is
Oh
part
yeah,
of
no,
the.
it's fine. I mean, it can. It's fine. They come in on
Okay.
it later.
All right. Tuan.
Just clarify, can you go back to the previous slide there, or to the specification? So
Yeah.
here your I is referring to a user, right?
Yes.
So alternatively, you could have a different specification when you think of I as like a house, right? Then you'll be asking whether
That's not where the level of randomization occurred, though.
I see. Okay.
Yeah.
I was thinking about the question of whether, like a house at a higher flood risk, are they going to be less likely to be viewed before and after the treatment, right? So.
We do get at that later by looking at the random distribution of homes where people were assigned high flood risk scores. So the level of randomization is on the user, but randomly in certain neighborhoods, like, 70% of users are going to see the flood score, but then in other neighborhoods, it might only be 30%. So we do try to exploit that variation to look at the effect on home values in these neighborhoods that got different exposure to the experiment. But we have a lot less power to do that, because it's not like, I mean, you have to cluster at the geographic level, and yeah, you just lose a lot of power. Okay.
Daryl, maybe you're
Go
going to
ahead.
explain that equation later. It looks like there's a lot of empty space below.
Okay.
But if not, I'm
Yeah.
just curious what the variables are.
Yeah, let me see if I
I
can get
assume
to
it
that.
comes up later and you say this, but maybe not.
Well, we do. Let me
can help
just
with
go
that.
through the slides. Or you want to help? Yeah, Sebastian.
If we go back to the, so remember, Glenn, you have, think about it, you have a dynamic entry into this experiment, right? You have a period where you didn't know anything, but you were already like, you have a before entering into the experiment that will be I, that like the B capital I. So you have 0 when you were before the experiment, and 1 once you are in the experiment. D is whether you were assigned to treatment or control. So that's irrespectively of the time, and the interaction of both is basically a difference for the treatment effect, which is beta 3. Because the beta 1 is basically taking you the sort of like time path of how people adjust their search, sort of a regression to the mean. Maybe you're searching for very high higher price things, but then you go down once you keep moving across time. And this is basically the at baseline, whether there's a difference between treatment and control, and interaction of both is
okay. Beta 3 is the diff and diff. I've got
exactly
that. All right.
And we're clustering at the user level.
Mm-hmm.
Yeah. Okay. Thanks.
Yeah, I guess it's just like things to consider that might vary between users is how long they were already searching for homes before they entered in the experiment, like what point they are in their search process might impact like how salient this information is for them. So yeah, we're trying to like account for what people were doing before they entered the experiment and control for that. Okay. And yeah, you can even see that the longer that you're in the experiment, it does change your behavior differently. The longer you're exposed to the flood, the more it seems to alter your behavior. All right, so search flood score goes down with the variance of flood score. So in this, we're trying to look at the variation within a zip code, with the thesis being that if you're in an area with a lot of variation, you're able to adjust your behavior more than if you're in a neighborhood with not much variation, or at least like the neighborhood that you're searching for a home in. So if all the homes have no flood risk, or all the homes have high flood risk, but you're committed to that neighborhood, you're probably not going to change your behavior as much as somebody who has a lot of different options in terms of flood risk within the neighborhood that they're searching. And that is what we find. The effects are concentrated in people where there's a high coefficient of variation and they were previously looking for high risk homes. Oh, and also it's explained by the Tversky model, where when people have better information, they're able to get to their preferred option faster. We have another result about search. Oh yeah, reduced search flood score coming from, oh yeah. So we also look at the different sources of flood risk within the First Street Foundation score, because there are these different variables that are flattened in just one score. One variable is precipitation, another one is sea level rise, and another one is storm surge. When we kind of need all three, or the more categories you have, the more you are impacted in terms of the homes that you're looking at. So precipitation alone, if that's the underlying cause of the flood score, doesn't have as much of an effect. But when it's precipitation and sea level rise that is coming up as a risk factor for you, you change your behavior more. And when it's all three, precipitation, sea level rise, and hurricane storm, then you are even more likely to change your behavior. To get at this new news concept of like whether for some homes the flood risk is obvious and for some homes it's not so obvious, and does that matter, we look at the search criteria of users. So when a user is baseline searching for waterfront homes, there is less of an impact. If you're searching for waterfront homes, you probably know the risks that come along with without waterfront homes, there's no impact. With waterfront homes, there is some impact, but it's when it is waterfront and not coastal that there is an impact. Sorry, I got waterfront and coastal confused. So if you're looking for homes that are on the ocean, you probably know right away that you're going to be facing some flood risk. If you are looking for homes that are inland, but have a waterfront view, perhaps of a lake or a river or some other inland body of water, you are somewhat impacted, but not as impacted as when it was on the coast. And when you're not searching for either waterfront homes or coastal homes, then you're not as impacted. Did I get that right, Sebastian? I feel like I'm tripping over my own words here.
You know it. It's exactly that
Okay.
the mechanism.
Yeah. Waterfront versus coastal. I kind of have to like remember which one I'm talking about. Okay. And we looked at what people are trading off, if anything, and we didn't really actually find that much here. People don't seem to be trading off home features like bedroom, bathroom, square foot size, or even price. Maybe there was an effect on the HHI of the zip code and the walk score, but it's still not necessarily significant. And also we're testing all these things, so I might just be over testing on that. But if you're interested in researching whether people are looking for homes with lower walk scores to trade off climate risk, there might be something there. I think it's worth looking into at some, if there's better data out there, but unfortunately we didn't have enough to measure an effect size there. Also, we later acquired fire, heat, and wind scores from First Street Foundation. So these scores were not a part of the experiment, but we knew ex post what the scores were for these properties. And we found that there was no trade-off happening across these different risk scores. It wasn't that people were trading off flood score for fire score, flood score for wind score. Maybe they were searching for homes with less wind score, but I have a feeling that's correlation on hurricanes. So we didn't see anything about trading off risk scores. It would be interesting to know if when people have all the information, do they make trade-offs? Because at this point we only had flood risk available. But unfortunately, we didn't run experiments when we added the other risk scores. I wish we would have, but we were just trying to, from a business point of view, get those scores on the website really quickly. So not time for a 3-month experiment on each score, unfortunately. Okay, and we think that the reduced flood score coming from the upfront risk score, may have changed. Sorry, let me back up. We had these different time frames for when a flood might occur. And we wanted to know which time frame mattered the most. Were people looking in that chart at the 30-year risk, or were they looking at the 0-year risk? We found the effect at the 0-year mark, like people seem to be mostly going off of the chance of flooding within that first year. But I wouldn't read a lot into this, because what people were probably mostly going off of was that score, that 0 to 10 score. And as you recall, from the previous slide, if you had a risk score of 8 or 9, then you had a much higher risk of flooding within the first year. So I'm not sure if people were going based off of the flooding in the first year, or just the red indicator of this home is severely or extremely risky, but they correlate, and that's the margin on which it was changing. So things that the search results did not vary by, definitely not property value, not neighborhood income. So we didn't see differing effects that might be interesting from like an inequality perspective. But we did see, we didn't see any changes based on political beliefs either. Like one thing we were curious about is if Democrats respond more to flood information than Republicans, but they responded equally. So that in of itself, I think, kind of, I think it shows that political beliefs maybe aren't that important in people's willingness or responsiveness to climate risk. So that in of itself, I think, is interesting. But these bands are pretty large. So I don't know. Maybe there is something that we're just not picking up on. But it seems for the most part that Republicans and Democrats responded similarly. All right, so yeah, we were wanting to look into the robustness of these estimates. One thing that we were worried about was whether information would scare people away entirely, meaning that we wouldn't observe their behavior. Like once you see flood risk on Redfin, that's it, you can't handle it, you're done searching. But we didn't see that. I think that's kind of a far-fetched story anyway. And we were also worried if it would affect people's willingness to tour homes in general or make offers in general. Like once I see the flood risk, I get scared off from buying a home entirely, regardless of the risk of the home, but we did not see that. And also, we're concentrating just on the high risk homes. So we wanted to make sure that we weren't falling prey to multiple hypothesis testing, but we did a Romano-Wolf procedure and the results remain intact. So we're good on that front. We're not over testing. Yeah, so this is about if scaring users away. There was not a change in terms of platform registration, like people registering as users. There was not a change in people viewing homes or the total homes viewed. Maybe a small effect on the high group of people viewing more homes, but yeah, no, it wasn't significant. Not in terms of time spent on the website, no effect on the number of sessions on the website or app. But we did find that people in the high category favorited less homes overall. But this could have been because they got more efficient at their search and needed to favorite less homes because the information was useful to them. It made them like better at honing in. So we saw this effect, but we don't think it was on a margin that would have impacted the believability of the experiment. It didn't change people's proclivity or intention to book a tour or have or cancel a tour. People went on the same number of tours and they followed through with them in the same amount, whether or not they saw the risk factors. And it didn't change whether or not they made offers on homes, on the probability of like going through and trying to buy a home. That stayed the same. But it did change the what is it, flood score, on the impact on the flood score of the properties that they ended up making offers on. Let me make sure. wait, no, this is like the main result. I'm just curious why it's on the slide. But anyway, you can see here that the flood score of the properties that people made offers on were over around 50% lower than what they would have seen if they were in the, or what they would have made offers on in the control group. Sorry, this is a big result, so I want to make sure I'm saying this properly. There was a statistically significant impact on the kinds of offers that people made. I said on the kinds of properties that people made offers on. If they were previously looking at high-risk homes, they went on to make offers on homes with about half as much risk as those in the control group. Okay, that's a big result. So I want to make sure I got that through. Yeah, and this was, we saw the similar effects from the waterfront searches. Let's go through that because we already talked about that. Okay, and they're not moving to more riskier places. They're not taking on higher fire risk or higher heat risk. Oh, sorry, this is the results for the stuff that they made offers on. So the offers results are very similar to the search results. We didn't see differing impacts in terms of fire, heat, or wind scores, not in terms of their affiliation or their geographic political affiliation. Oh, and this is also, I think, a pretty cool result, is that the information helps with allocative efficiency of all types. That is a fancy way for saying that people took fewer days to make an offer on a home when they had information about flood risk. And that was true for people who were previously looking at low risk homes, medium risk homes. High risk homes was actually the opposite. It was the one that had the least statistical significance. So different than the outcomes of making an offer at the time was like a little bit weaker for high risk homes. But I think there's an easy story here to tell that when you know for sure that the set of homes you're looking at don't have flood risk, it makes you feel more confident about making an offer on that home. Same true for medium risk homes. For high risk homes, I think it makes sense that the impact would be lesser, because maybe seeing that the homes that you're previously looking at had high risk would make it harder for you to find a home that was suitable for you. Any questions on that piece of it? I find this part really cool. All right, I'll keep going. All right, so we try to do an equilibrium analysis. We're still working on this part, so welcome to hear feedback. Let me just skip to. Okay, so when we're looking at the outcome variable being homes, maybe I should look at this for longer, but basically what we're going to do is we're going to try to see if there's an impact on the prices of homes sold based on how much exposure areas got to the experiment. And Sebastian, I might need your help explaining this part, but the basic idea is that a 1 percentage point increase in the exposure intensity alters the value of homes sold, and it seemingly doesn't. There's a negative effect for the high risk homes, but it's hard to identify. Okay, but when you look at the new news sample, so homes that are not coastal, where people do not know necessarily upfront what the flood risk is of homes in the area, there does seem to be a measurable impact on the value of high risk homes. Am I saying that correctly, Sebastian? Maybe you want to jump in here.
So the idea here is, we got a robust result on Redfin users, and we wanted to jump ahead and say, was there actually an impact broadly on the whole market, right? And our mechanism was, for each listing that is listed in Redfin, which is basically all of them, we have every day or across time a percentage of users that always saw the treatment, right? And you had a percentage that never saw the treatment. So theoretically here, the idea is like there were some listings, some housing that randomly were at a higher level exposed to these things. And we're trying to use this shock to the question that Tuan or someone else was saying about, one thing is how it affects users, and the other thing is how it actually affects the whole property. And this is what we are seeing here, that you can see or read here, there were properties 10% of the properties had actually 50% of the users, of people that browse through Redfin, had access to the treatment, and 50% not. And then on the other end, if you go, there was almost 1% or 0.5% or 0.1, where 80% of the users that saw all the time this property had access to the treatment, and 20% not. And this is the percentage of people that saw the treatment is what Daryl was saying. By increasing 1 percentage point in a property that has more people that actually view the treatment overall, they did have an impact in sell prices, and it's kind of like an intensity effect here.
Yes, thank you so much, Sebastian. I think like another way just to frame it is that the research question we're trying to answer in this portion of the paper is when more people know about flood risk, does that change the value of high risk homes relative to low risk homes? So we can kind of get at that because there is this natural variation at a geographic level in terms of how many people know about the flood risk. But it's pretty weak because there's not a whole lot of variation. Also, Redfin is just one option for viewing listing information about homes. There's also realtor.com, zillow.com. Realtor had flood information up for every single user at this time. They were before us. Zillow did not have any information yet. They added it after this experiment. So I think these are small changes in the number of home searchers that are seeing flood risk versus not, but it's enough that we can at least try to exploit that small amount of variation. Okay, and when you're looking at all the listings, we didn't see a significant impact, but in the geographic areas that were not coastal, we did see an impact for the high risk homes with their sale values being negatively impacted. And I know I have the precise number later. Oh yeah, here we go. So if you extrapolate this like very small variation, like 1 percentage point on a good day out to 0 to 100, which is a pretty big linear extrapolation, the number you get is that home values were impacted by $6.9 thousand. And if it was the whole market that had high flood risk, then it would be $80,000 of impact. Yeah, so these are some other cuts of the data that didn't have a statistical impact. So I won't focus on that, but I'll repeat. So this is a good breakdown of the results. So yeah, going from 0 to 100% in the natural field experiment for a geographic area leads to a price penalty of $6,800. But yeah, caveats, because not all Redfin users were part of the experiment, and there's only 20% market share of users at the time. People might use multiple sites. So it's hard to estimate it. But if you assume a linearity in the impact, then you would expect an $85,000 change in price. Sebastian, was the $85,000 for high risk versus low risk, or is this for a whole geographic
This is
area?
for the whole.
But it's the high risk homes that are going down in value.
Oh, the 85,000
right?
is for the high risk. No.
Okay, for the high risk. Okay, yeah. So if you had a home that had high risk instead of moderate risk, then it would get $85,000 lower value if every single person viewing that home knew the flood risk. But take that with a huge grain of salt because of all the caveats. And we're working on trying to get at this number in different ways to improve this part of the analysis. But this is a part where the experimental variation doesn't get us very far. But we think this $85,000, maybe it's believable, because if you were to average the cost of flood damage, according to FEMA, it's $66,000. So if somebody knew that they were going to incur $66,000 in flood damage over the course of a certain number of years, and there would also be maybe some personal emotional harm to them, then maybe this $85,000 value difference makes a lot of sense. But grains of salt all over the place. Okay.
We're just about done. If you got a couple more
Yeah,
slides.
I think this is my concluding slide. So
excellent. Okay.
Okay, so overall, what do we know? We know that people are impacted by, or people's search behavior, the way that they engage with properties, is impacted by knowing about flood risk. It changes where they look, and it changes in terms of geography, where they look for homes, and also changes properties they look at because they're looking at homes with lower risk. And we also know from this experiment that it's not just their search behavior, they actually make offers on homes with less risk when they have this information, especially if they're looking at higher risk homes to begin with. And, we can extrapolate that if people are making offers on lower risk homes when they have that information, that they are gaining something in value there, and that they're, if we extrapolate it out, that this means that home values aren't perfectly capturing flood risk. So we think that this is new news. We have other reasons to believe it's new news. And if it is new news, then we should see home values change over time as more people have access to flood information. All right, I think I already went through all these caveats, so I won't harp on that. And I'll just summarize by saying what's happened since this experiment finished. Redfin now has flood risk on every single home for every single user. You can see it, including other risks such as fire, wind, heat, and air quality. And our competitors, Realtor.com, CoStar Group, and Zillow, have also added these same risk factors, also from First Street Foundation, as of today. So this information's out there. So more people that use it, the more it's probably going to change the market in the ways that we've discussed. All right. I'll just open it up for questions here.
Yeah, Daryl, thank you very
I'll
much.
leave this on the screen, but
okay, that's fine.
Sparks any questions?
Thank you for your presentation. Let me stop the recording here.